So we've got the goggles on, we've got the ear protectors, a lab coat to protect from any shell pieces that fly off from the grinding, and I've got some gloves on to protect my hands as well. So the first step today is to trace the outside of the positive on the 3mm polypropylene blanks, and that way we can get rid of any excess material and make the pressing process as smooth as possible by getting the shape of the positive. That way we prevent any wrinkles while still allowing the shell to come up high enough to support the anatomy of the foot. So see that we've laid the positive on, and I've also done it on the other side just in advance there. So now what we're going to do is we've cut out the polypro blanks and we're going to put them in the oven. Obviously, I'm indicating here that we're going to put the smooth side down, and that's going to be on the outside of the shell there. So we're putting in the oven at 425 for 3 minutes, and that's going to make sure that the polypro gets nice and soft and pressable, but we're not going to do it in such a way that's going to let it burn. Otherwise, that's going to cause problem for the material there. I'm just going to wait and heat it up. So the polypro is in the oven, and I'm going ahead to put the positives in the vacuum press, keeping them off of the ground on the supports there, and that's going to allow the polypro to really wrap well around the positive. Alright, so we can see that the timer is just about running down there, so what we're going to do, we're just going to turn that off, and what I've done actually is I put on some cotton gloves to make sure that I don't burn myself when I take the poly out of the oven, as it is at 425 degrees Fahrenheit for about 3 minutes, so it's quite toasty. And what we do, you just separate the heel quickly to make sure that we get a good separation and lift off. And then we go ahead and place the shell as we outlined it along the positive, and making sure that we don't put it too far back that it's going to wrinkle around the heel, and we don't put it too far forward that it's not going to give us enough material to create the 16mm heel cup that we want. So through the vacuum bladder, the rubber bladder, we can see that there isn't any wrinkles forming there, and this is again for the other side, going ahead and placing that on there and closing it, making sure that there will be enough clearance for good heel cup shape and forming around the positive, but also no wrinkling. And so what we do, we wait until the shells have taken the form of the positive and have gotten enough time to cool. Alright, so we're going to leave the polypro in the vacuum for about a minute and a half, as you can see here. Alright, so the polypro is cooled and ready to come out of the vacuum press. So you can see there, we take out one and we check the contour of the shell to make sure that it's really tight against the positive. Take it off, and we'll do the same thing for the other one there. What's really important to see here is if there's any wrinkles or bumps or anything that's going to cause the shape of the shell to be deformed from the smooth shell that we're familiar with. We want to make sure that that there's good contour along the medial and lateral columns, really capturing the anatomy of the foot. And so now that it's cooled and we know it's going to hold its contour, we're going to just kind of pry it off gently. I'm using that screwdriver there, trying not to get into any of the edges and cause damage there. And what we want to look for once it comes off is the really good shape, right? We want to look inside to make sure that there's no lumps or bumps or wrinkles from the manual dressing there that would have translated. So on these ones here, we also want to check the arch heights to make sure that they are similar to what we see on the positives, and check the heel cup that we will have enough space. And we'll do that a bit later. Now that we've inspected the shells, we can go ahead and kind of cut away some of the excess polypropylene along the outside of the shell. And again, being in the lab, we have some of the perks of having the bandsaw, but if we were in a clinic and didn't have access to the bandsaw, we would use a grinder. So again, I mentioned measuring the heel cup, and so you'll see here that we actually take a little bit of time just to make sure that we have enough and that the cut that we're making isn't going to reduce that heel cup for us. So we've taken off the extra material, and now we're going to line it up against the shell, and you've seen that we've drawn the bisections of the first and fifth ray there on the shell, and that's going to tell us how wide to grind the device or how narrow. I've left myself a little bit of extra room just in case I make a mistake, and the same thing here with the heel cup. We have a special device, again, perks at the lab, that allow us to draw a line around the outside of the shell to tell us where to grind to see where the heel cup will be. And it would be the same thing in the clinic. We would just have to be a little bit more low tech. So now that we've got that, we've got the heel cup, and we're going to grind the edges to get the nice contours that we're used to seeing in an orthotic shell. So now that we've got the outline of the width of the device and also the height of the heel cup, we're going to go ahead and connect those two on the grinder. So grinding off any excess of the shell, that's going to bring the shell into the width that we want for the patient. So that's going to be more of a standard width. And what I'm doing is I'm just carefully bringing it perpendicular to the grinding wheel. Otherwise, it could create some sharp surfaces on the dorsal edge that could dig into the patient's foot, the soft tissue, or even the top cover and really damage that material depending on how soft it is. Using the wire wheel there just to take off any of the polypropylene that forms on the grinding edge. That's going to create a big mess. We want it to be nice and clean, nice and smooth, with good transitions throughout in order to really capture the anatomy of the patient. So in connecting the anterior distal end of the shell to the proximal part, the heel, we want to make sure that we have nice smooth transitions along the medial and lateral arch. Otherwise, we're going to get weird lumps, and it's going to be hard to fit and not look very nice aesthetically. And that's part of the device, making it look like a professional device. And we want our devices to look professional as clinicians. So also, it's really loud. I've got my ear protectors on still, and I've obviously taken off the cloth gloves so that I have a really good grip on the polypro shell. I'm going to go now and go ahead and do the heel cup, having drawn that line, going nice and slow, holding it in a safe, strong position to make sure it doesn't fly out of my hands there. So you'll see that I'm bringing the grinding wheel more and more into the shell to create that heel cup depth that I want. And in that position, I am going to really get a nice flat heel cup there, nice flush heel cup at the top. And then I'm going to connect the medial and longitudinal arches from the distal aspect that I grinded earlier for the width to the heel cup height aspect right through, connecting the medial and longitudinal arches proximally and distally. So here we're going to create the outside edge of the shell and really bring down the thickness of the medial and lateral borders of the device. We want it to be fairly uniform throughout the device, otherwise it gets quite chunky and it will have difficulty fitting into a shoe as well. So we're going to go ahead and smooth those out, making sure that all the borders are uniform and creating that nice square outside edge. And that'll help us later when we're putting it on the top cover to create the right angle so that the top cover is flush with the shell and it doesn't hang over or it's not too short and inside there. Just pressing it lightly against the wire wheel. That's going to help smooth that out as well. So we've got the shells shaped to the way we want them, and now we're going to just check them up. They are the same left and right feet, and it does take someone with quite a bit of skill to make the dressing quite somewhere between left and right. So we are just going to make sure that they look similar. So we checked the lateral column, and now we're checking the medial column. Just checking the height of the arches, proximal to distal, and making sure that they have a similar contour. And here we're just going to go ahead and check the length of the shells, putting them on a flat surface so that we don't get a misinterpreted indication of how long they are. We're going to go ahead and grip them along the medial and lateral border to line them up widthwise, and that way we can see if they line up properly on all the outside edges of the shell. Now that we've got the shells to the desired shape, we're going to go ahead and smooth out the distal transition of the shell. And we want to do this because we don't want any lumps or bumps for the patient to feel as they move through the device and into the toe-off phase through the mid-stance there. So we're going to go ahead and hold the shell carefully with two hands, bringing it up against the grinder to really smooth out that distal edge, making it not sharp, but we do want to thin it out because otherwise it comes down to a comfort thing. And if we don't make the device comfortable as much as we can to remove any of those transitions, there's going to be low adherence to actually using the device, and then it just sits in a closet or it sits in a shoe. And we really want to make sure that our patients are using the devices that we design for them, because then they can really help with the biomechanical issues that they're facing or other pathologies that may be affecting them, like diabetes So now that we've got the shell transitioned and shaped properly, we're going to go ahead and put on a rear foot post on this device. So like the notes say, we're going to center the device, and again in the lab we have a little bit of a cheat sheet, a template marker. It's a size 9 foot, and we're going to put it about 10 to 15 millimeters proximal from the center of the seat of the heel there. So we're going to go ahead and draw a line so we know where to place the 12 millimeter 70 durometer EVA. So we're going to go ahead and put the rear foot post on the polypropylene shell now. We've got our 12 millimeter EVA in the oven. It's about 70 durometer, and that's going to be a nice sturdy rear foot post for this device. I'm going to go and put my cotton gloves back on, as the EVA is quite hot and I don't want to burn myself, keeping safety in mind at all times. So when putting on a rear foot post, it's really important to keep a really good contact between the shell and the material. Not really pressing it on too quickly. We want to stretch it across the planar aspect of the shell to make sure there's no lumps or bumps. Otherwise that's going to affect the lamination between the shell and the material. Again, here at the lab we do have the vacuum presses. At a clinic without one, it might be a little bit more difficult. You'd have to really make sure the seal is nice and tight. But here we can put the shell up against the positive and put it into the vacuum press, and that's really going to help to create that really strong seal between the EVA and the polypropylene. And we're going to actually put another piece of polypropylene just distal to the rear foot post material, and that's going to keep the EVA nice and straight up against that piece. Otherwise it could start to deform down, and that will affect the stability of the posting. First off, you can see that I made the mistake of not putting my ear protectors on before using this grinder, but that will be remedied in the future. And we can see now that I'm using the flat belt grinder to take off the material of the rear foot posting that's plantered to the shell and not up the sides. And we want to make sure that we're going slowly, just to make sure that we don't actually grind through the material into the shell, weakening that shell integrity that I was talking about earlier when we were doing the abrading. So I'm going nice and slow, just checking to make sure that there isn't any probability of damaging the shells as I'm doing this. Now that we've bottomed out the rear foot post, we're going to go ahead and bring it up to the grinder, being very careful not to thin out the walls of the shell as we're taking away the material from the side of the rear foot post. If we grind too close, we can damage, again, the integrity of the shell, making it weak and likely to crack. So we're going to give it about 8 to 10 degrees of a side cut. We don't want to leave too much on there, otherwise it might create too much control in the patient, and we don't want to cut too much away, otherwise it might not control it to the degree that we wanted it to be. So we're going to give it that nice in between to make sure it gets the desired effect. And we're bringing the device up to the finishing wheel now, just to smooth out the rough edges from the belt grinder and also the wire wheel there. Just to make it nice and smooth so that it looks aesthetically pleasing, as well as there aren't any, again, any rough bumps or transitions from the shell to the patient's foot to the ground, because they'll be able to feel all of that as the shell is quite fitted to the arch and is in good contact with the plantar aspect of their foot. So again, making sure not to over buff the outside of the shell, otherwise we could cause damage. So the devices are now ground off and finished. So you can see there the two finished devices just with the nylon strike plate on. Just some selections of pictures. Here's the medial arch of both feet just up against the positive. You can see really good arch contact there and contour. And again, the lateral arches of the left and right foot. Really good contact and good cupping of the fill as well. And again, in the heel, nothing spilling out. Hopefully this will translate to the patient's soft tissue. And that's the device.